Hello, welcome to Lionheart Academy. This is Richard Tai. This is our 5th lesson for trigonometry. Today we're going to talk about arc length. In the previous lesson, we have already discussed many aspects of measures of angle, especially in radian and in degree. We will continue that discussion today. Arc length is a very important aspect of using radian. Now, when we talk about arc length, we are usually looking at an angle or a circle or a curve. That's where usually we have arcs with circles or curves. Okay, so when we measure arc length, we're basically asking ourselves, what is the distance you have traveled on a certain segment of the circle, like this. From that point, okay, let me give it a label a little bit more. Let's label the center of the circle origin as O, and let's label this point A, let's label this point B. So this is an arc. This is an arc, and usually we call it S. Okay, so how do you determine the size of the arc? There are several ways we can do this, but it usually involves the central angle that intersects the arc. So if we draw a central angle starting from O to A, okay, as you can see, OA and OB, segment OA and segment OB are radius. Okay, so let me put that in the arc. They're radius. They are radii of the circle, and they intersect this arc S. Okay, and as we realized before, the angle formed between those two R's, those two radii, is an angle theta, and this angle theta is related to the arc S. In fact, if you remember the definition of radian for an angle theta, the definition of radian is theta equal to S over R, S divided by R. So that means we can solve for the radius, we can solve for the the arc length of the circle if I know the radius, if I know the angle theta in radian. So S is equal to R theta. This is the equation that we're going to use to help us solve for arc length, and theta is in radian. Okay, so theta is the measurement of that central angle in radian. So S equal to R theta. That seems to be very straightforward. Okay, so let's look at the example. Okay, so example, if the radius, all right, let's say we have radius equal to 4 inches and a central angle that is 240 degrees. So let's go ahead and find the arc that's being subtended by that angle. Okay, find the arc. Okay, find the arc S. So we have radius of the circle is 4 inches. The angle of the central angle is 240 degrees, and we want to find arc S. Now, first of all, if we look at the formula, S equal to R theta, we realize, oh, theta has to be in radian. So we don't have radian right now. So what we need to do is we need to convert theta into radian first. So remember the conversion ratio? The conversion ratio was pi over 180, or 180 degrees over pi. Now in this case, because we want to convert from degree to radian, so we put the pi on top and we put 180 degrees on the bottom. Alright, now let's go ahead and reduce this. 240 divided by 180, we can reduce it by 10 first. So reduce it down to 24 pi over 18. The degrees cancel out. Now 24 divided by 18, we can further reduce them. Now I think they are the greatest common factor here now is 6. So we can reduce 24 by 6, so it would give us 4, and reduce 18 by 6, it would give us 3. So the correct radian measure is 4 pi over 3. Alright, so now we can use our S equal to R theta equation. S equal to R theta, so let's substitute R, which is 4 inches, and substitute theta in radian, which is 4 pi over 3. Okay, so let's multiply together. This would be 16 pi divided by 3 inches. You can leave the answer like that. That's an exact answer. Or if you want to go ahead and calculate an approximate answer, once you use a calculator or use 3.14 for pi, you can calculate the approximate answer. It's about 16.76 inches. 76 of hundredths of inches. Okay, so this is a very straightforward thing, but let's go and try another example and see what happens. All right, so let's go ahead and try this. So given, okay, so let the radius be equal to 15 centimeters, and the central angle, let the central angle be let the central angle be 16. Hold on. 135 degrees. Okay. So and then find the arc. Find S. All right. So think about this. What should we do first? We have the radius. We have this angle. We can find the arc. However, the angle is not in the right measure. So we have to. It's not in the right measure. So we have to convert data from 135 degrees to radian measure. Again, we got to multiply by that conversion ratio. The conversion ratio again is pi over 180. Okay, so we are going to multiply this by pi over 180. So again, it's 135 pi over 180. All right. Now the degree cancels out. Okay, now 135 and 180, the smallest common factor I can see is 5. So we divide 130 by 5. If you divide 130 by 5, you should get 27. Divide 180 by 5, you should get 36. Alright, now I see they also have a common factor of 9. So divide that by 9. 27 by 9 is 3. Divide 36 by 9 is 4. So 3 pi over 4. Okay, so let's go ahead and find S now, because now we have R and theta in the correct measure, in the correct format. So R is 15 centimeters, and substitute R 15 for R, and substitute 3 pi divided by 4 for theta. So this will give us 3 times 15. This is 45. 45 pi divided by 4 centimeters, and you can leave the answer just like that. All right. We have discussed the degrees, minutes, and seconds before, but let's go ahead and do that, and then let's discuss this one more time, okay? And then we're going to do some calculations. Again, so 1 full rotation, revolution, is equal to 360 degrees, okay? So 1 degree is further divided into 16 minutes, which is use 1 slash, okay? And then 1 minute is further divided into 60 seconds. Okay, so this is a very interesting, very useful things, especially in coordinations, GPS, and then things like that. Well, let's go ahead and see how we can go ahead. What we need to do is how do we convert a degree, minute, and second into degree only. Okay, so this is going to be very useful, and also let's go ahead and see how we can convert a degree to degree in minutes and seconds. So let's take a look at one example here. So let's say we have 42 degrees, 30 minutes, and 36 seconds. Okay, so let's see. Let's say we want to convert this to degrees only. So how should we do it? First of all, let's start with the minutes. Let's start with the seconds, excuse me. So I know 36 seconds. Okay, 36 seconds is 36 divided by 60 minutes, right? Because each minute has 60 seconds, so 36 seconds is 36 out of 60 minutes. So let's reduce that. That's 1 reduced by 6, so it will be 6 divided by 10 minutes, or reduce it or if you convert this to a decimal, you could convert this to a decimal or reduce this to a simpler fraction. It will be divided by 2, it will be 3/5 minutes, or 0.6 minute. Okay, so now let's combine this with the minutes. So now we have 30 and 3/5 minutes. Okay, or we have we can write as 30.6 minutes. Okay, 30.6 minutes. Now, so that's the amount of minutes that we have. But how many degrees is that? Well, if I want to convert this to degree, I would have to take this and divide by 60. Okay, degree. You will convert this to 60 divided by 60, and so this will be 30.6 over 60 degree. Now, how much is that? Well, what we can do is we can take a calculator. We can use a calculator and just basically type this in. So let's go ahead and try that. Use 30.6 divided by 60. So you get 0.51. So this would be exactly 0.51 degrees. Alright, so now we're in decimal mode. So finally we can combine the degrees with the rest of the 30 minutes and 36 seconds. So it will be 42.51 degrees. Okay, so as you can see, we started with the seconds, then convert seconds to minutes, and started with the minutes, convert minutes to degrees. Every time we convert, we divide by 60 because 1 degree has 60 minutes and 1 minute has 60 seconds. So that's 41.51 degrees. Okay, let's try another example here. Alright, what about 330 degrees, 25 minutes, and 20 seconds. Okay, so let's start with the seconds of, again. So it's 20 seconds is 20 divided by 60 minutes. 20 divided by 60, you can reduce that. It becomes 2/6 minutes, and also that means 1/3 minute. And 1/3 minute in decimals is approximately 0.33. It's 0.33 repeating. Okay, so we're going to add this to 25 minutes. So we have 25 and 1/3 minute. 25 and 1/3 minute. And let's go and convert that to a decimal. It's approximately 25.33 minutes. Okay, and so let's convert the minute to degrees. So it's 25.33 repeating minutes divided by 60 minutes. So that becomes a degree. Okay, that becomes a degree. So what do? We go ahead and take this and use a calculator. So it's 25. Okay, one way to make sure we have exact decimal is we actually have to use 1/3 here in fraction. That will give us a better approximation here. So you do 25 times 1 and 1/3. So okay, and then divide that answer by 60. So you get 0.42 repeating degrees. So then finally we go ahead and add a degree to this. So we get 330.42 repeating degrees. Okay, so that's how we convert degree minutes and seconds into degrees only using decimal systems. Now, how about how do we convert a degree only to degree, minutes, and seconds? Sorry, put the wrong symbol here. So how do we convert degree to degree, minute, and seconds? Alright, let's do some simple example here first. If I have 240 degrees, 0.6 degrees, okay? How do I convert that to minutes? Well, look at the decimal part here, it's 0.6, right? So let's look at that 0.6 degree. So let's write it in a fraction. So 0.6 is simply 6 divided by 10. Is that true? 6 divided by 10 is 0.6, right? And so this is degree. Now we want to convert to minutes. We have to multiply. We have to convert this into something over 60. Okay, because something, this is a numerator over 60, that will be the minutes. So if I have 6 over 10, how do I convert that to x over 60? Well, to get from 6 over 10 to x over 60, I have to multiply by 6 in the denominator. So in the numerator, I also have to multiply by 6. Then we would end up with 36 over 60. So that 36 is going to be our minutes. So it's 36 minutes. So therefore, 240 degrees and 246.6 degrees is 40 degrees and 36 minutes. Because 36 minutes is equal to 0.6 degrees. Alright, let's try another one. Okay, now let's try, let's see, negative 145.45 degrees. Alright, so let's take a look at the decimal. Okay, 0.45 degrees. So 0.45 degrees is the same as 45 divided by 100. 45 divided by 100 degrees. Okay, so we want to convert this to x over 60. Okay, so that means we want to convert this to something over 60 because 60 is the number of minutes in a degree. So let's set our ratio. 45 divided by 100 equal to x over 60. We can solve for 60. We can solve for x by cross multiplying. Okay, so let's go ahead and cross multiply. Alright, so it would be 60 times 45 divided by 100 equal to x. Alright, so let's use our calculator to help us. 60 times 45 divided by 100, that would give us 27. So x would be equal to 27. So coming back to this, that means negative 145 degrees, 0.45 degrees would be negative 145 degrees and 27 minutes. 27 minutes. Alright, so I think that's enough for today. This is our lesson for today. Please leave any questions. If you have any questions, please leave your questions and comments in the comment section below. And then hope you will subscribe to the series of videos that we're doing. And we hope to see you next time. We will continue to talk about measure of degrees. And thank you.